Hi, my name is Florian from Quality Guru. I answer your questions and share knowledge about quality management. And today I talk about APQP, Advanced Product Quality Planning, which is an automotive quality planning guideline and tool which you can use probably also in other industries. So let me hear if you are familiar and if you are using APQP, if you find it interesting. And if you like this video, please hit the like and subscribe button so that you get notified whenever there's a new video. Let's go right in. So quality planning in general has the task to make sure that the next generation of product or services is meeting all the customer requirements, that we identify all the risks from the beginning and that we control the risks in the next generation of product or service. And by this we make sure that we have the highest possible customer satisfaction and the lowest amount of problems and rejects. And by doing this, this is based on the principle of front loading, that we should put a lot of effort into the early stage of the product planning and the service planning, that when we design our project or product, in terms of time, in terms of people, resources, in terms of effort spent, so that we can identify all the problems in the beginning before we go then into the full-scale production or delivery of our services when we get the problems. And here we can see that most of the problems are generated normally in the creation concept development phase, but they're not realized. And then we carry them over into our product designs and into our process designs. And then we make mistakes when we do this, and then our customer realize them when we start delivery and they start using our product, and then we have the problem because they find out that this is not what they expected and they give us the product back and they say, no, I don't want this, I reject this. And we have to bear the cost and we have to correct all the issues in our product, maybe in the design, maybe in our machines, maybe in our tools. And this is a lot of investment which we want to avoid by taking this risk out from the beginning through proper quality planning. And in order to standardize this quality planning process, the AIAG, the Automotive International Action Group, has standardized the quality planning process in 5 phases, and they call it the APQP approach, which is the Advanced Product Quality Planning methodology, which basically says you should structure your process in those 5 phases, and each of those phases has an input and an output. And if you put the right input into this each of those phases and you control the right output of each phase, then you will ensure that you advance in the best possible way and avoid most of the possible mistakes you can make in the process. So let's have a look. What are the phases? Phase 1 is planning. So in the planning phase, normally we discuss with our customer about the order. We receive the order. We want to make sure that it's performed in the best possible way. So we have our design goals. We start with the preliminary bill of material. We have our first process flow. We identify the critical characteristics for the quality. And with this in mind, we then move on to the product design and to the process design and development. So they move in parallel. So in most companies in the automotive industry, we have a design department which focuses on the product design. So how do I need to design my product that it meets all the functional and quality requirements what the customer is needing. And on the other hand, we have the manufacturing guys who are the persons who need to produce this, and they work in parallel. Why? Because if I design something what looks very nice and I cannot produce it, it's useless. And if I have a very great production process but my design has a lot of failures, then it's also useless. I cannot reach the targets like this. So they must both move in parallel and ensure that they work together on certain outputs. Like for example, on the design FMEA, how can I identify all the possible failure modes in the design and already cover them or control them by the design, for example through pokayokes in my assembly parts, that I can only assemble them together in a certain way that doesn't allow for a failure to happen. And then also in the process FMEA, that means how do I define my identifying all the risk in my assembly process or production process, and put already the countermeasures in place. Like what kind of controls do I need? Where do I have most of the risk? And how can I control those risks? Maybe I can even go back from the process FMEA to the design FMEA, give the feedback about the high process risk, and ask the designer, can you cover this already in the design? And we also have our first drawings. We start with our prototype. We validate all our planning in terms of testing. And we also have design for manufacturing. That means how can we design this part that makes it the most easy and simple to assemble later, so that it can be cost efficient and also meet the quality requirements. And then looking forward into the process design and development, we're looking also here at how will we package these parts, what will be the process flow, what will be the layout, what will be our FMEA, what will be our control plan, what kind of controls do I need to have in place in order to ensure that everything is working perfectly. All my gauges, what kind of gauges will I use, my whole quality control concept I need to develop and finalize it before I go into the next stage, which is the product and process validation. So here I will validate and see if everything what I did is really working in the way it should work. So I will run my product, my production line, my production process at a certain rate, what the customer is requesting, maybe 50 pieces per hour, 100 pieces per hour, and I will see if I'm able to deliver parts within specification, even if I run at a very fast production rate. And I will also do my validation testing, see if the parts coming out of this line can meet all the requirements in terms of testing, in terms of appearance, in terms of dimension, whatever criteria is relevant for the customer. And I finalize also my control plan, and then I go into the production phase. That means when the customer then gives me the PPAP, check out my video about PPAP, PPAP, if you don't know what it is. So if the parts then get, and the assembly process and basically the project gets released and I'm allowed to ship parts, so then we go into the production phase and we will start daily or weekly shipping the parts to our customers so that they can use them in their production process. At the end, and this is the final phase, you should do an assessment and a lessons learned process. All what you learned, and now that you are in the production process and you are getting feedback from your customer, you can see if that what you have planned out really works or if there are problems. And if there are problems, you should take them into consideration, learn from them and feedback them. That means this is basically going backwards into the next project, into the planning phase. So what we want to see here is that we want to learn from our mistakes. We want to collect all the feedback from the customer, from all the existing projects, what we're doing with our customers, and then take these experience, all the failure we have made, and feedback them into the next generation of products. Why? Because like this, we can try to avoid them in the next generation, and by this get a lower and lower rate of problems, a lower rate of defects, a lower rate of rejects, a lower rate of failure cost, but a higher customer satisfaction and a better position for the future. So this is the APQP logic, this is the APQP plan. I hope you find this helpful. If you like this kind of video and you get value out of it, please hit the like and subscribe button so that you can get notified whenever there's a new video. And I hope to see you in the next video.